I wanted to go over the operations of the machine visually as well as I've typed it all out, and I'll send it in the email. But the coil would drop in. Keep in mind this coil is just a representative coil of the minimum and maximums. So an actual coil is an inch smaller on the inside. And so this would drop in. It would go down until it hits the rollers. And then the operator would pivot all of the guarding into place together so that no matter where they're at around the table, each one of these hinge points would be a handle. I'll extend the shoulder bolt and put a handle on it. So they would pivot the guarding into place. When they pivot the guarding, I'll have a cam on the back of one of these with a pneumatic switch that allows the controls to work. This is intended to be spring-loaded, so I've got 8 rollers on there, just like your current machine. Each one would have a sleeve around it so it actually rolls. It's not bolted into place. And then I've got a torsion spring and an eccentric mount where this will remain pivoted into place all the time. And then as the operator engages that, if the coil was to pop up, this latch wouldn't move up and down. But if they're in a position where this is in the way, they could pivot this back, flip this up, and be able to get at that strap easier. So everything would move manually on the guarding. So they've moved it into place now. The limit switch allows the controls to work. The operator's going to use the controls to squeeze the coil, which, depending on where the coil is at, that's, everything's going to move into place. Then the operator would remove the straps. They would rotate the coil, the end of the coil, until it's in line with the outlet. We talked a lot about the in-between the rollers. So let me hide this for a second. So I think the best way to handle that is to put plastic there so that it would, we talked about if you had multiple rollers in there, it's got to thump, thump, thump over all those different rollers. What you have now is working okay, even though these rollers aren't really rolling because they're bent. So I figure the best way to do that is just, I'll put a piece of UHMW in between every one of the arms that comes in and grabs the coil. So the operator with the coil squeezed would pivot this around until the end was even with this outlet. I've only got one opening in there, a couple inches wide, so it should be easy for them to get it in place. And then they would use the controls, well, then they could clamp to this plate like they're doing now, and then they would use the controls to release the coil and be able to pull the coil out through the exit. This model is 90% of the way there. Because of the length of this linkage that operates the pinch rollers, I picked up some extra gear ratio. And so I didn't model any of the controls because this gearbox is 50-to-1 like your current gearbox. Actually, it's 60-to-1. Anyway, it's just like your current gearbox. I'm going to only need a 20-to-1 gearbox in order for it to move at the same rate that it is now, which is pretty slow, basically 1 inch per minute. So to keep it at 1 inch per minute of motion, I'm going to do a 20-to-1 gearbox, which means that I'll have to model the new gearbox and the mount for the gearbox, which is where I'm going to put the controls at a later time. But this gives you some idea of what we're talking about. Mechanically, it's going to move mechanically now. So a single Acme threaded rod and some linkages underneath. Like I said, it's 90% of the way there. I didn't want to do all of the motion linkages to put all 4 in place, but the computer knows what's supposed to be there. And so hopefully this is covered everything that we went over that Tuesday. Let me know if there's any other questions. Thank you.